Morning. This lesson is 1.3, and we're going to try to annotate it a little bit differently. I was having trouble with my draw feature, so I'm going to see if I can use this pen feature down here in the bottom left-hand corner, and we'll see how that goes. But this lesson is about linear functions. So this is where we are going to look at our terms here. And so just what are these forms of linear equations, and that we will be using them a lot. Slope-intercept form is possibly the one that I find most students are familiar with, and it's y equals mx plus b, where m is the slope and b is the y-intercept. Now the y-intercept is a point, and that point is when x is 0, and then the y value is whatever b is there, okay? Intercept form is generally ax plus by equals c, and you might wonder, why is one b capitalized and one's not capitalized? Well, they're really not the same b. This lowercase b over here is slope-intercept form. This capital B is not. It's just the number in front of y when it's in this arrangement. Okay? And then average rate of change we will look at, but average rate of change really is essentially slope. It's just that slope is what we refer to when we're just dealing with lines. And if we had some sort of a word problem, then we don't talk about the slope of the problem, but we're talking about an average rate of change. But when we do our algebra, we can, in fact, use slope to help us write an equation that would apply there. So linear functions always have a steady rate of change. That's what keeps the line straight. Things that don't have a steady rate of change is going to curve as it goes along. But since this line is straight, it's got a steady rate of change. Whatever you're doing just keeps happening again and again and again. So slope is that term for that steady rate of change. And the formula for slope, if you have 2 points, so let me just kind of write that down. If you had 2 points, and we call both points are going to have an x and a y, but if I just say x and y both times, then those points actually look identical. And so for us to distinguish, we put a little subscript here. That should be a 1 on both of those, and then a 2 on both of these, so that we can just tell the points that came from the first point or the second point, and the order makes no difference. If you put 2s on both of those and 1s on both of those, it'd be fine. So your equation, slope, is y2 minus y1 over x2 minus x1. So it has to do with how much you're going up for how much you're going over. So it's often called rise over run, okay? Because we are moving as we go along. That's one way to kind of remember that M stands for slope, because you want to think slope, why isn't that S? But it has to do with your steady movement as you're going over and up, okay? This is a little clip from what a homework problem might look like. So it's not actually one of our homework problems, but it's for us to look at it. It lists input and output values for a function. And it says, is the change in the inputs x the same? And so what you do is you just go along here and you think, okay, from -9 to -6, they have added 3. And then look, going down, they added 3. Added 3, and you want to check that every single time. So every time they have added 3 to the x values. Now over here on the y values, what is happening? Well, if you go from -29 to -20, you have increased by 9. And so we want to make sure, is this an increase by 9 every time? -20 plus 9 is -11, plus 9 is -2, plus 9, plus 9, plus 9. So all of those increase by 9. So I kind of went ahead and did it together, but is the x inputs the same, or the change the same? Yes, and it's equal to 3. Are the change in the outputs the same? Yes, and it is equal to 9. So is the function linear? Yes. Now, it doesn't ask this, but what would be the slope? The slope is the change in the rise, so the change in those y values, over the change in the x values. So the slope would be 9 over 3, which is just 3. Okay, now they didn't ask that, but that's an extra feature to that as you just look at the x and y values across the way. Now these are screenshots from problems, just so that you can kind of see what your homework will look like. It says find the slope containing the given points, and it's awfully hard to read those points. I get that, so I'm going to write them down. This point here is 0, 8, and this point is 3, 0. So now you can travel vertically and then horizontally from point to point, and you can say, okay, if I go from this top point and go down 8, and then I go to the right 3, and that gives you your change in rise over run. So I can tell by looking at this that the slope is actually negative 8/3. The slope, oh, I don't know why that happened. Slope is often going to look like a fraction, but you don't necessarily have to think of it like a fraction because the two numbers actually represent something different for us, okay? Those two numbers are representing the rise and the run, so they're two different features along the way. Now let me see if I can get my 3 there. Okay, so again, if I were going to deal with the formula for slope, I would take one of the points and then the other point. I would think of them as x1, y1, x2, y2, and I'm going to fill in that formula. M is equal to y2 minus y1 over x2 minus x1. And then do that math straight across. 0 minus 8 is negative 8. 3 minus 0 is 3. And so you see I get the same answer both ways, either traveling vertically and then horizontally, or applying the formula. So now this next one says find the slope if it exists. So I'm going to apply the formula first on this one, and I think you can read those points. So if I have negative 1, negative 2, and 1, negative 2, and I want to apply the formula, this second y value, it's y2 minus y1, oh, I don't know, again, minus y1, I shouldn't have a comma there, and then x2 minus x1. Now, when we do have a minus a negative, it does essentially make it a positive. So I'm just going to try to change colors and do that one for us. And then as we finish this out, going straight across the top, negative 2 plus 2 is 0. 1 plus 1 is 2, but 0 divided by anything is 0. So the slope of a horizontal line is 0. There is no rise. So again, if you did a vertical and horizontal movement, your vertical movement is none. So 0 divided by, and then this horizontal movement would be 2. So again, that is 0 divided by 2. And you can still get the same answer that way. But horizontal lines have a slope of 0. But a vertical line, I'll go ahead and write that down, would have a slope that a lot of times on the homework it's going to say D and E, and so that means does not exist. Sometimes on textbooks they will actually say that it's no slope, but I think that your online homework actually says does not exist there. So that's just kind of a side note, not part of that other problem over here. This one, again, is just another example, but it has to do with fractions because I know a lot of people don't like fractions. So if we're going to do this, we're just going to apply our formula. We've got x1, y1, x2, y2. It really doesn't matter which one you make first. I just always do it kind of from left to right as they're there. So slope is equal to y2 minus y1 over x2 minus x1. Now again, because we have that minus a negative does make that same as positive actually, so we can change those signs along the way there. So 1/4 plus 1/2, of course you're welcome to use a fraction, to use your calculator with the fraction key. I'm just going to kind of go through this. So 1/4 plus, I could change 1/2 and call it 2/4. 1/4 plus 2/4 is 3/4. And then on the bottom, my common denominator would be 8. So I'm going to multiply both the numerator and the denominator here by 2, and 1/4 will become 2/8. So 2/8 minus 3/8 is negative 1/8. And just to refresh you, and if you have to divide by a fraction, one of the key things we say a lot of times is keep, change, flip. Keep the first number, change it to multiply, and flip the second one over. Okay, keep, change, flip to divide by a fraction. Then once you change it into multiplication, we go straight across from left to right. So that's going to be negative 24 over 4 by multiplication, which comes out to negative 6. Okay, so a graphing calculator will have a fraction key on it. So if you've got your graphing calculator, I'm going to show you, I'm going to bring up a graphing simulator here and show you how you can enter that. All right, so to get you a fraction on your updated calculator, even though it doesn't say this, so you might want to write it down somewhere. There's nowhere that says this. You go to alpha y equals, enter, and it lets us just do this little fraction thing. So then y2, remember I'm doing y2 minus y1, only I need, that means at the top here, I need to put a fraction. So just like over here, when I had a fraction in my numerator, I'm going to do that again. Alpha y equals, enter. And so now I've got this 1/4 that I can put in my numerator, and I'll end up doing that several times. Minus alpha y equals, enter. So that was 1/4 minus negative 1/2. And then we're ready to do the denominator. But again, within the denominator, I have fractions. So I'm got to get my fraction in there. And then we had 1/4 minus, I have another fraction, 3/8. Then I'm going to go to the right to get behind this entire thing. So I click to the right twice. So this, you know, is one of those scary looking things, but it's there. And I'm going to hit enter. And bam, negative 6, which is what I got. Okay. So anytime you're using your graphing calculator, you're not quite sure what to do with, there's tons of help on the internet. You can just, you know, Google, how do I do such and such on a TI-84? And you will find the tips like for entering fractions or something like that. Here's our next slide. So this is changing up the type of equation that we're dealing with. We've got 9x plus 2y equals 10, and it says slope and y-intercept. But this one is not in slope-intercept form. So there's more than one way to do this. If you know another way, I'm certainly not stopping you. But what most students do is they rearrange it by just using algebra. So if I do minus 9x, and then I'm going to squeeze it in right here, minus 9x, then those will cancel, and my result is 2y equals negative 9x plus 10. Divide both sides of this equation by 2. But now make sure that you recognize that when you divide an equation by 2, each part of that gets divided. So the result here is y equals negative 9 over 2x plus 5. Now you certainly could have put negative 4.5, but it doesn't help to do slope as a decimal, because this indicates to me very clearly that this line goes down because it goes down 9 and over 2 every time it moves. So the slope is negative 9 over 2. And then the y-intercept, they're going to want you to put it as a point, is 0, 5. Now, for what it's worth, I'm just going to put some extra points up here, because the more you do something, the more you start to recognize patterns. Since every time we rearrange an equation like this, you end up taking the x term over and then dividing it by what's in front of y. If you think about that as being ax plus by, the slope, not just this time, but always when it's in that form, ends up being the opposite of a, because when you bring it over, it changes the sign, divided by b. So if you just look at that, the opposite of 9 divided by 2 is negative 9 over 2, and I wouldn't have had to do all that writing in red. Also then the y-intercept, the b value, that little value for the y-intercept, can be found, again, if this is c, it's 10 divided by 2. So it is whatever that last constant is divided by what was in front of y. And I can just get these numbers then by looking at an equation, just because I've learned that. But again, it's not necessary. Most students do all the writing that you see in red. Now find the slope and the y-intercept of the line with the given equation. Well, if y is equal to negative 18, if you can just kind of visualize this on a graph, then somewhere down on this y-axis, there is a negative 18. And this line actually runs, I wish I could have hit that well, but this line runs horizontal through that point. And so this is a horizontal graph, and we talked about that before. The slope of any horizontal line is 0. Okay? And if there's only y in the equation, it is a horizontal line. So let me just kind of put a note over here for you, that if it says y equals a number, the only thing that matters is how high do you put the line, because it goes everywhere from left to right. So that one is horizontal, and the slope is 0. If you have an x equals a number, and that's all you have for your equation, that's the one that's vertical, because the question is, what x do we want to put it at, because it uses all of the y values. And this is the one where your slope does not exist. So now, again, just a little snapshot from your homework. If you had an equation, even if there's a lot of words there, if you look right here, we actually have our algebra equation. And it says that the D stands for the depth in feet, and the P is your pressure. Okay, find the function values. So this actually means you need to plug in numbers. So we are just going to plug in now, and then graph the function. Well, the easiest way to plug in a value is to use your graphing calculator. There we go. So I'll show this both ways, but with 0, you can kind of do it by what we call inspection. Well, let me write them both out in case you're doing it by hand, and then we'll do it with our graphing calculator. So this would be 1 over 33 times 0 plus 1. Well, 0 times anything goes away, so we're left with a 1. 1 over 33 times 66, because that's our next value to plug in, plus 1. Well, 33 will divide into 66 2 times, so 1 times 2 is 2, plus 1 is 3. And then the last one, 1 over 33 times 132 plus 1. Well, I know 132 is just twice as big as 66, so 33 is going to go under there 4 times, and that will end up giving me a total of 5. Okay, now back to that graphing calculator. How would that have worked on the graphing calculator? The fastest way to do it is to go to y equals, and I'm going to type in this equation they gave me, alpha y equals enter, so that I can type in that fraction. I have 1 over 33. And go to the right to get behind my fraction. Even though the equation up here has a d, your calculator is not, what you really just want to use most of the time is this key right here for a variable. It doesn't, your calculator doesn't care what the variable is. So I'm just going to put an x. Now if you really wanted to have a d, there's a way to do it, but that's not going to be efficient for you really. So I've typed my +1, and now I'm going to go up here above graph in blue. It says table. So I go second graph, and it brings up a table. Now, I have mine set so that I can just type in any number I want to, and it gives me an answer. But if yours is going 0, 1, 2, 3, 4, 5, 6, 7, then you need to do a setting. So let me show you where that is. Right up here above window, that says TBL set, so table set. So if you go second window, this is the important part right here where it says ask. You need to put your independent on ask. And if your independent is on ask, then when you go to your table, you can just type over those numbers and they're not going to clear out. But like I needed to plug in a 0, a 66, and a 132. So I can go 0, enter, 66, enter, 132, enter. And you see I got 1, 3, and 5, which is exactly what I got over here doing this by hand. So using your table feature helps you plug things in very quickly, and your calculator doesn't make any sort of, multiplication errors or something, so that can be pretty nice for us. Let me just click back over to where we are. Hang on right here. All right, so now if we wanted to choose the correct graph, you really want to choose the graph then that has, this is like your x value and your y value. So you're looking for a graph that has 0, 1, 66, 3, and 132, 5. So the thing that I can see is that my really only A and B are even close to reasonable because they're the only ones that are going up. Okay, and my numbers 1, 3, and 5, they are getting bigger as my other ones get bigger. So you're looking for something that goes up. But additionally, the 0 gave me a 1, and this one right here is a problem. You can see on that graph A because that one is at a negative value, so that can't be it. So even though you can't quite see this, you can tell. Now you can often tell a little bit better if you will click this thing. Now this is a picture of your homework, so I can't click it right now, but that helps enlarge your graph so that you can see what's going on. So the correct answer here is B. Also, when you were on your graphing calculator, if you typed graph, you can tell that that goes up. Now I don't have my windows set like theirs. So again, just as we're learning about the graphing calculator, if I wanted to check some of that, I could go to my window and see where it says X minimum, X maximum. I can look at what this graph actually has. This X-axis started at -50, and it goes all the way to 350, and they've counted by 50s. So you see I typed -50, 350, and then that SCL stands for the scale, which is your count by. My Y values on this graph B, if I want to check it, they started at -10 and they went to 10. So both of those are already okay, but they didn't count by 1s. It looks like they've counted by 2s. So now when I graph it, I get a window that looks a lot like that one. It's kind of that same size, so I can have some confidence on the way there. This is actually a screen from your homework. I've gone into it as if I am a student. So again, just trying to help some people. I've already filled out the slope and the y-intercept for this particular problem. But I've had some questions about graphing. So let's look at this graph. When you want to graph, the easiest thing to do, first of all, is make it big. Pop it out, this third little button here. So click the pop out. And then you choose your shape. So I'm going to choose a line. Now, if you can't get the line in the right place immediately, you don't worry too much about that. You can adjust it, but I think I can on most of my straight lines that I'm doing. So I know that the y-intercept is 0, -2. You can still see that over there. So 0, -2. And then it has a slope of 4. So I use that by going up 1, 2, 3, 4, and then go to the right 1. Because what you have to remember is the slope of 4 is the same thing as 4 over 1. Now when I click Save, it puts it here and it's in blue, and we're ready to check the answer. On the other hand, I've already checked it, but if it weren't in the right place, then you can click on it and move some points around. So let me see if I can do one more with you. This one is just ask me to graph it, but it doesn't have anything written here. So I'm going to use, it says use slope in the y-intercept, but I'm not real sure that that's the way I want to do that one, because this one is more in intercept form. And intercept form is really geared into the fact that I can just play cover up, you know, with those things. So if I cover up, I can get my values. However, don't forget that I said I can get the slope by the opposite of B over A. So my slope is going to be +3 over 2. But I can't quite use that yet because I have to know where to start. The y-intercept is my beginning point for this. And I can get my y-intercept from this type of equation by 24 divided by -3. So 24 divided by -3 is -8. So I'm going to get a line, I'm going to put it here at -8. And then I'm just going to put it somewhere because I want to show you particularly how you can edit. Even though that line is there, I know it's not in the right place. So I'm going to click that. And now I can either drag it, or notice I can click Edit Coordinates. And so if you want to click Edit Coordinates, you can type directly in there. Okay, but you don't have that option until after you put the line on there and then click something. Okay, now I can also say, well, I said that this was 3 over 2 for my slope. So I can say, okay, from here I'm going to go at 1, 2, 3, and to the right 2. And there we go. And that may have been where it was in the first place, but that would have been lucky because I wasn't paying any attention to that. So anyway, I just wanted you to see how you can do that on your homework along the way. So I hope this helps you out, and don't forget to use that Ask the Instructor if you need some help.